pag-ingon diri, we can also get the change in position from the velocity time graph. Okay, sige balik ta. So this is again the position versus time graph and then the velocity versus time graph. Ingon siya diri, we can get the change in position. So in the previous topic, unsa ganitong change in position? So the change in position is denoted by delta S. We call the change in position as the displacement. Diba? Tapos ito'y delta V na to. We call that the change in velocity. Change in velocity. This one is change in position or the displacement. Delta V is change in velocity. Ingon siya. Sa V, so velocity times time graph, makuha na to ang change in position or the displacement. So, naa siya example. This one. So, on this side, on kaning first graph na to makita is the velocity v dash t graph or the velocity versus time graph. So, this is the origin. Let's say this is the time 1 and then here, this is the initial velocity v naught. So, mo nitong graph diri sa velocity, no? Ingon siya nga, gikan aning velocity versus time nga graph, makuha daw kuno nato si displacement. So, ang displacement, ani nga graph is this one. Kung mo ang time 1, magbuhat kag line dira. And then, imo nang i-shade, ang area ani nga na shaded part is the displacement, no? That is the displacement. Now, unsaan man nato pagkuha sa area? So, the best way to get the area, actually, the area on this side is just the integral of the velocity with respect to time from 0 to time 1. So, more na siya change in velocity. I mean, change of position is equal to the integral of VDT. So, I would like you to recall again that, diba, velocity is just equal to the derivative of the position over the with respect to time, or the change in position, which is delta S, over the change of time. So when we are only given the velocity times time graph, then we were asked the change of displacement, then we can just use this formula again, no? Gibalik-balik lang yun, V is equal to ds over dt. So dire ang giingon lang niya is change of position. So, ang gibuhat is mura ra gyapon na siya ds is equal to v dt. So, nganong delta s ang gigamit diri, dili man ds nga ds man ni. Because if we integrate s to and then here with respect to time, so 0 to time, and then here from 0 to s. So, kani siya nga side, this is the initial to the final. So, kani siya nga side, may mo na siyang s minus the initial position equal to, ako lang i-remain nga niya, integral of the velocity with respect to time from initial time to final time. And then we know that final position minus the initial position is the displacement. Diba? We recall in the previous chapter that delta S is equal to the final position minus initial position. So that's why we have that delta S is just equal to the integral of the velocity with respect to time. Muna siyang v dt. So pagbasahan is velocity with respect to the integral of velocity with respect to time from initial time to final time. Okay. So mura ni siya. And then, so asa man ni nato makita? So here below the velocity times time graph, we have the position versus, velocity versus time. We have the position versus time graph. So here we have the position and then here the time. So in same scenario, we have the time 1 here. So kaning first point, this is the initial position, and then kaning S1 is the final position from 0 to 1, of course. So ang delta S is kaning change sa position. Mao ra gyud na siya. Mao ni siya ang delta S. Change in position. So mura ra kag nag-ingon nga same ra gyud po natong first sample nato, di ba nga from origin, let's say naa si particle at this point. So this is S. This is the initial position, S sub S naught. And then this is the final position. Let's say this is S. So para makuha nato ang ang yang change. Therefore, si delta S is just equal to the final position minus the initial position. So yan po ni siya. So mara niya itong dumduman niya po na delta S or the change of position is equal to the integral of velocity with respect to time. Okay, so mara siya. Kani siyang area is delta S. Kani siya diri nga distance, tawag nato na siya displacement or delta S or change of position. So in the same way gyapon no, kung di ba from velocity giatras nato to position, makuha nato gikan ni velocity ang change of position. So in the same way gyapon mao gyapon si acceleration. So on this right side here, upper right, ang graph nato diri is acceleration versus time graph. So this is the acceleration on the y-axis, also known as the ordinate. And then on the x-axis, also called the abscissa, is the time. So, muna siya ang graph sa acceleration. So, at time 1, time interval 1, ubos ani niya nga graph, ang area niya ani. So, from velocity paatras, ang area ani is change of position. So, ang acceleration paatras, that is the velocity. So, ang area di ani is, we call that the change of velocity. So, same gyapon. So, iyang giingon po diri is that, the change of velocity daw is equal to the integral of the acceleration with respect to time from the initial time to final time. Or let's say T1 man iyang gigamit diri, so T1. And then diri 0, nganong 0? It is because nagsugod na ta sa 0. But if pangayuan ta nga from diri to here, then let's say this is T2 and then this is T3 and then ang area diri. So same ra gyapon, the change of velocity is equal to the integral of acceleration with respect to time from initial time nga within ani nga limits which is T2 and then to T3. So ana siya. So nganong delta V, sir, nganong change in velocity? So mo gyapon to no ato i-recommend nga change na siya from final minus initial. So kung si delta S na atay final position minus initial position na po tay velocity, ang change of velocity is just equal to final velocity minus initial velocity. So we know that the formula, di ba nga, naman to A, kung natin V is equal to ds over dt, natin A is equal to the derivative of V with respect to time. Diba? Remember? And then, kung ito na i-chuchu, cross multiply, we can get dv, derivative of velocity, is equal to acceleration with respect to time. So, if we integrate both sides, so ang velocity with, so from, this is from initial velocity to final velocity, and then this one is from time, initial time to final time. Then we will have on this side v, final velocity minus initial velocity is equal to the integral of acceleration with respect to time from initial time to final time. Okay? So inyo makita, di ba? Final velocity minus initial velocity, that is just the change of velocity. So change of velocity then can be makuha ning sample or graph, that is just the integral of the acceleration with respect to time from initial time to the final time or T1. So, ano siya? Munang pag-abot diri, so this is the change of time. So, ang change of velocity. So, ang change of velocity is just the initial velocity. final velocity minus initial velocity. That's why here, the graph shown here, so this is the acceleration versus time graph. This is the velocity versus time graph. So, mo ni siya ang V initial. This is the V final or the V1. Kani siya nga distance diri, we call that the change of velocity. Okay? So, mo rin ni siya. Change of position or displacement is just equal to the integral of velocity with respect to time. So this is the area under the velocity versus time graph. And then the change of velocity is just equal to the integral of acceleration with respect to time. So change in velocity is equal to area under the acceleration versus time graph. So kani siyang area is just equal to acceleration, integral of acceleration with respect to time.